students. So today in this video we will learn how to prove the Thales theorem or the basic proportionality theorem. So this is the statement of the Thales theorem or the basic proportionality theorem. So what is Thales theorem? So for example, if in a triangle, let's suppose triangle is ABC. In this triangle, if I draw one parallel line, so this line is parallel to BC. Let's suppose this point is D and this point is E. So if in a triangle a parallel line is drawn and this line should intersect the other two sides at two distinct points, then this line will divide the other two sides in the same ratio. That is, AD divided by DB will be equal to AE divided by EC. So in this video we are going to prove this, how we can prove this AD divided by DB is equal to AE divided by EC. So let's start. So first given. So what is given? A triangle ABC is given, and in this triangle this DE parallel to BC. Then to prove, what we have to prove? We have to prove the ratio of their sides are equal. That is, AD divided by DB is equal to AE divided by EC. So given, to prove. Next, to prove this one, we have to construct something. This one, construction. So in the construction, what we have to do? First, we have to join BE and CD. First, we have to join this BE line and then CD line. Then one more construction is needed. Also draw, here we have to draw one perpendicular line. For example, this one DP is perpendicular to AE. DP is perpendicular to AE. And another perpendicular line we have to draw. That is, let's suppose EQ is perpendicular to AD. EQ is perpendicular to AD. So given, to prove construction. Next step is the proof. Now proof. So see, here I can see one triangle. That is the triangle ADP. And in this triangle, if I want to find out the area of this triangle, so how can you find out the area of this triangle? Let's suppose if I consider the altitude is DP. So what will be the area of this triangle? Triangle ADP is equal to half into base is what? Not P, this one is E. Base is AE into height is what? Height or altitude? It's the DP. This one you give equation number 1. Now, in this triangle, if we want to find out the area of this triangle ADE, I can take the different altitude, that is the EQ altitude. So what will be the, in this case, what will be the area of this triangle AD? This one, not P, ADE. So ADE is equal to half into, now in this case base will be AD. AD is the base into height will be EQ. This one you give equation number 2. Now we can see another triangle. That is the triangle BDE. In this triangle, if I want to, for example, it is an obtuse angle triangle. In case of obtuse angle triangle, we can take the exterior height. So what will be the area of this triangle? Area of triangle BDE is equal to half into base will be DB. DB into height will be EQ. This one give equation number 3. Now another triangle I can see here. This triangle name is DEC. It is also obtuse angle triangle, and sometimes in case of obtuse angle triangle we can consider the exterior height, that is the DB. So what will be the area of this triangle? Area of CDE. This will be what? Half into base is EC into height is DB. Now see, here DP is there, here DP is there. Now divide the equation 1 by 4 and equation 2 by 3. Now divide equation 1 by 4. So left hand side divide this divided by this, then this divided by this. So what we will get? Area of ADE divided by area of CDE is equal to right hand side half into AE, half into AE into DP divided by half into EC into DP. Now half can cancel, DP can cancel. So what is left? Area of ADE divided by area of CDE is equal to AE divided by EC. Okay. Now divide this one, we can give equation number 5. Now divide the equation 2 by 3, because here EQ present, here also EQ present. So now equation 3 divided by equation 4. So what we'll get? Equation 2 is divided by equation 2 divided by equation 3. So what we get? Area of ADE divided by area of BDE is equal to what we get? Half into AD into EQ divided by half into DB into EQ. Now EQ can cancel, half can cancel. So what is that? Area of ADE divided by area of BDE is equal to AD divided by DB. This one will give equation number 6. Now see, in equation number 5 and equation number 6, area of ADE is same. Now if we can prove the area of this triangle and area of this triangle is same, then we can equate these equations. Now look, here we have one quadrilateral. That is the quadrilateral BCDE or BCED. In this quadrilateral, this line and this line are parallel. And between these two parallel lines, two triangles lie. One triangle is CDE and another triangle is BDE. And we know one concept that if the two triangles lie between same parallels, then their area must be same. what we can write? Triangles on a common base and between same parallels are equal in area. So you see, in case of triangle BDE and CDE, both the triangle they have the common base, that is the DE, and both the triangle they lie between the same parallels, that is the DE parallel to BC. So their area must be same. So area of CDE should be equal to area of BDE. Now we can compare the equation 5 and 6. So what we can write? From equation 5 and 6. So from equation 5 and 6, what we can say? See, area of ADE is equal to area of ADE. Now already we proved area of CDE is equal to area of BDE. So that means left hand side is same. So we can equate the right hand side. So from the right hand side, what we can say? AE divided by EC is equal to AD divided by DB. So that one only we wanted to prove, isn't it? So AD divided by DB is equal to AE divided by EC. So proved. So in this way we can prove the Thales theorem. Thank you.